Okay, Algebra 1, Section 3.3. We're talking about the transformation of linear functions. So we introduced function notation last time we were together. So when I look at this is a function called f. The way we read this, f of x is 2x. Next to it, I have another function named g. G of x is 2x plus 4. So let's look at these two functions. So if I look at them, we'll say that f of x is 2x. When you plug in a negative 2, you're going to get a y value of negative 4. Let's stick with the function f. Plug in a negative 1, you get negative 2. Plug in a 0, plug in a 1, and plug in a 2. So let's graph that function. So I've got, these are my x values, and these are my y values. So at negative 2, negative 4, that's right here. Negative 1, negative 2, 0, 0, 1, 2, and 2, 4. So I know that this one has a slope of 2. So let's draw this guy. So if I insert a line, for that, there I go. So this is my line f of x equals 2x. Now if I graph g of x is 2x plus 4, I plug in a negative 2, I get 0. Plug in a negative 1, 4 minus 2 is 2. Plug in a 0, plug in a 1, and plug in a 2, and I get that. So in this one, here are my x values, and here are my y values. So negative 2, 0, negative 1, 2, 0, 4, 1, 6, and 2, 8. So this one again has a slope of 2, okay? So I see similar things that are going on here. Let's look at graphing this guy. So if I graph this guy right there, so there we go for this one. And this is the line g of x equals 2x plus 4. Now I already know from what we did in our last unit that when I look at these two, that slope is 2, right? So slope is 2, and this one as well, the slope is 2. So these are parallel lines. Now if we want to look and see what is the relationship between these two lines. So how do I, if I started with the blue f of x and I shifted to the red g of x, what is the transformation? So let's just look at it point by point. This point moves to here. This point moves to here. This point moves to here. So in every case, 1, 2, 3, 4, I'm moving up 4. So I'm moving up 4 every time. So the transformation is that g of x equals f of x plus 4. So when I say g of x, that's the y value. F of x, that's the y value. So if you take the y value of the blue line every time and add 4 to it, you get the y value of the red line, okay? So I can describe this then as the transformation. So if I look at this transformation, I have moved the line that was the blue line up and to be the red line. So what you see here is I have moved 4 is a vertical transformation up. That was the transformation from F to G. Now, what I can also do is I can look at the transformation going left, transformation going left, transformation going left. So what I see here is that this is 2, and it's a horizontal translation to the left. It's a different way of describing this transformation. So I've got 2 ways of describing this transformation. If I look at this, the easiest way to describe this is the y values. So the y values are going up by 2, or excuse me, up by 4. It's sort of easy. It's a little bit harder to describe the x translation, so we're going to focus more on what happens with the y. So algebraically, without a graph, what I can see here is that g of x is what happens when you take every y value in f of x and you add 4 to it. Okay. Now, if you look at the algebra, what happened, I had 2x and 2x plus 4. So f of x was 2x, and g of x is 2x plus 4. So the only difference between these two functions is I added 4, okay? So you can clearly see if you added 4 to f of x, you get g of x, okay? So if I look at this one, the next one, f of x is 3x plus 1, and g of x is 3x minus 5. So what I'm concerned with, in order to figure this out, all I need to do is, how do you turn a plus 1 into a minus 5? Okay, so if I make that happen, so to turn that into a plus 1 into a minus 5, I look at it and say, okay, plus 1, to get to a negative 5, I have to go down 6. So 6 units down in order to make that happen, okay? Now, if I want to figure out what the horizontal translation is, easiest way to think of this is a line that has a slope of 3. It's a positive slope, right? So it's a line that has a positive slope. So if I look at this, a line that has a positive slope, which means if this is 3, this is 1, okay? So if you wanted to recognize that the same thing is going down 3, in order to get back on the line, you would go left 1, okay? So if I look at this, if I went down 6 units, so according to the slope, if I went down another 3, if I went down 6 units, I would have to go to the left 2 units to even that out, okay? Pardon me, I need to back up on what I said on the last guy here. I got the left and right mixed up. So let's look at this again. So slope of the line has a slope of 3. Okay, so that means 3, 1. Okay, now if you were to move this line, okay, down 6, okay, so that means you're going to go down 6, and then that distance would be 2. So if I were to move this line down 6, okay, so here, so this total, if this was 3 and 3, this means I went down 6. The other way that I could have made it happen is if the line went this way, if the line went to the right. So the slope was 3, so 6 over 2. So it would be 2 units to the right in order to make that equivalent. Okay, so that's an equivalent move from left and right. Okay, so the vertical shift is a little bit more straightforward. So in y equal mx plus b, bx is the vertical shift. It moves the graph up and down without affecting the slope of the line. Okay, so if we look at this, I have this one in the middle. This is f of x equal x. Well, if you go up 2, that's f of x equal x plus 2. Go up 4, f of x equal x plus 4, and so forth. So the number on the end, which is the y-intercept, moves the graph up and down. Okay. Now the other thing I can do with lines is I can multiply them by a constant. So f of x equal x. So when you plug in a -1, you get a -1. So you plug in all of these numbers, you get the same values. Now what if g of x is -2x? So here's your x. -1 times -2 is 2. Plug in a 0. -2 times 0 is 0. Plug in a 1. -2 times 1 is -2. Plug in a 2, you get -4. So what is the transformation that takes me from this number to this? you're multiplying by -2. So you multiply by -2, let me make that a little bit clearer, times -2. Same thing here, times -2, times -2, times -2, okay? If I look at h of x as 2x, well, basically it's 2 times that number, -2. 2 times this number, 2 times this number, and 2 times this number. So I'm multiplying by 2. And then if j of x is 4x, I'm taking each of these numbers, multiplying by 4. So this transformation, I'm not adding, moving it up or down, I'm multiplying the number. So what's happening is I'm scaling the y value. So if you look at, you have some function f of x, and you multiply it by a number. If the number is bigger than 1, you're stretching this. You're vertically stretching the graph. If it's less than 1, you're compressing the graph. So when you look at f of x equals some number times x, that m is the vertical stretch or compression of the graph. Okay, so if I look at this, what's happening here, let's find f of x equal x, which is right here. F of x equals 2x is doubling all the y values. So you look at this y value right here of 2, when you double it, you get a 4. That's 2x. This y value is at 4, you double it, you get an 8. Okay. Look at 3x. Here's a y value of 2. Triple it, you get 6. Okay, that's f of x equal 3x. And then if I go the other direction, this is a 2. Take half of 2 and you get 1. So this is half x. You take 2 and you divide it by third, you get 2/3. So that's f of x equal 1/3 of x. So by putting a number in front of the function, I'm scaling it. I'm basically multiplying the function. So let's describe the transformation of f of x equal 1/2 x minus 2. Describe the transformation that results in a function with a slope of 2 and a y-intercept of 8. Okay, so describe the transformation that takes 1/2 x and gets me something with a slope of 2 and a y-intercept of 8. So f of x is 1/2 x minus 2. Now what am I going to have to multiply to get a slope of 2? Okay, so I'm going to have to multiply by 4 in order to get a slope of 2. Okay, so if I multiply by 4, that gives me what? 2x minus 8. Okay, so the y-intercept here, here my y-intercept is -8, right? So if I'm going to get a y-intercept of 8, okay, so keep in mind this one's a -8. To get a y-intercept of +8, I'm going to have to add 16. So here's the transformation that has to happen. I have to multiply this thing by 4, and that gives me 4x minus 8. But to get a y-intercept of +8, I'm going to have to add 16 to that. So what it means is I'm going to stretch the graph vertically by a factor of 4. And then I have to move the graph 16 units up. Okay? So I'm just breaking down the two things that have to happen, the multiplication and then the addition to make it move up or down. Describe the transformation of 4x minus 3 plus 1 to g of x equal 3x minus 1 minus 4. So let's go ahead and distribute this out. F of x is going to be what? 4x minus 12 plus 1. So that's minus 11. G of x is going to be 3x minus 3 minus 4. So 3x minus 7. So what do I multiply? I got to multiply this to get a 3. So you're going to have 4x minus 11. I have to multiply by 3/4 in order to get a slope of 3. Okay, so what does this give me? This gives me what? 3x minus 33 over 44. What I need to get is 3x minus 7. So minus 33 over 4 plus something equals negative 7. So let's just call that a variable x. So x is going to be 33 over 4 plus negative 7. It is what? 33 over 4 minus 28 over 4. So that is what? 5/4. So I need to be able to add 5/4. So what happens is this transformation is I multiply, so it's going to be 3/4 4x minus 11 plus 5/4. So that means I'm going to compress. I'm multiplying by 3/4 by 3/4, and then I'm moving the graph 5/4 up. Describe the transformation of negative 4/5 x minus 1 to 2x plus 1. So this first graph is going to be what? Negative 4/5 x plus 4/5. And I need to turn it into 2x plus 4. So I'm going to have to multiply. So what is it? Negative 4/5. I need the 5 to cancel, and then I'm going to have a negative 2. So I'm going to have to multiply by negative 5/2. That's how I get a 2. So I'm going to take this first function. I'm going to multiply by negative 5/2. So this gives me 2x, and then minus, when I multiply negative 5/2 times 4/5, that's going to be minus 2. But instead of a minus 2, I need a plus 4. So I'm going to have to add 6 to that. So the transformation is negative 5/2 4x plus 4/5 plus 6. So I'm compressing this by a factor of, well, it's 5/2 it's more than, that's more than 1. So I'm stretching it by a factor of negative 5/2. And then I'm moving this guy 6 units up. Let f of x be 2x plus 1. Describe the transformation of 4 times f of x. You're basically just multiplying everything by 4. So you are stretching the graph by a factor of 4. And there's nothing out here, so there's no additional moving it up or down. So all the y values are getting multiplied by 4. Look at the function here. F of x is x plus 1. If you want to graph 2, x plus 1 plus 2, well, what you do, you're going to double the y values, okay? So you multiply, so you 2, so you do a vertical scale, basically double the y values, and then you go up 2. So if you double, here I'm sitting at a 1. If you double that, you get a 2. Go up 2, you get a 4. Here I'm sitting at 0. Double that, you get 0. Go up 2. Negative 1. Double that, you're at negative 2. Go up 2, you're at 0. Sitting here at a 2, double that, you get a 4. Go up 2, you get a 6. If I'm sitting at a 3, double that, you get a 6. Up 2, you get an 8. So what I see here is the line that goes through all of these points. Now, what is the graph of this line? I can tell the slope is still 2. This is 2x plus 4. Okay. Actually, I did this backwards. I should have done this. The first one said to do, let's back up. The first one said to do the vertical scaling, the movement first and then double. So if I go up 2, like I'm sitting at 1, go up 2, I'm at 3, double it and I get 6. Here I'm sitting at 2, go up 2, I get 4, double it, I'm at 8. Here I'm at 3, double it, I get 6, go up 2, excuse me, oh no, sitting here at 3, add 2, I get 5, double it, I get 10. Here I'm sitting at 0, go up 2, double it, you're at 4. Negative 1, go up 2, you're at 1, double it, you are at 2. Okay, so I get this particular line. But if I do it the other order, if I do the scaling first, I'm at 1, double it, I get 2, up 2, I'm 4. Sitting at 2, double it, you're at 4, go up 2, you're at 6. Sitting at 3, double it, you're at 6, go up 2, you're at 8. 0, double it, you're at 0, go up 2. Negative 1, double it, you're at negative 2, go up 2, you're at 0. So I get different lines based on which one that I do, okay? Now, which one is correct? So clearly, this means up 2 and this means double, okay? Look at order of operations. Order of operations would tell you to do what? It would tell you to do the multiplication first, okay? So this one is correct because it follows order of operations. So anytime you've got two things going on with a function, here's x plus 1, I'm doubling and I'm adding 2, multiplication comes before addition. So that's the one that you would do first. And that should lead us up into to homework for this particular section.